Welcome to Shadow PV. There was a long time since the last video because I focused very much on my German YouTube channel. But today we spoke another topic that's very important to the Victron ecosystem. So, the Victron bypass. It's explained in the Victron Unlimited guide, but as viewers contacted me, they have problems with their systems. Often the bypass switch is installed incorrectly. So is it that difficult to understand? This is what the Wiring Unlimited guide tells you. It's recommended to add such a manual bypass switch to an inverter charger system, especially for mission critical systems. When you have the switch, you can bypass the inverter and charger and connect the consumer circuits directly to the grid. So when you make updates, maintenance or other things, when you have to turn off the multiplus, and so the loads on the AC out won't be with voltage, so you need the load that you can run them in the meantime. The thing that's sometimes misunderstood, that you can see here two switches down here, but in real life only one switch is needed and some circuit breakers, but I will show it later. The problem is that most of the electricians knows only this system. You have this load transfer switch here and the grid here and some kind of inverter. And down there the consumer circuits, and the load transfer switch is used to use either the grid or the inverter. But in the Victron system it's quite a bit different. We will see that later. So I have here two pictures from some viewers. They had problems with their systems, especially the RCDs quit their job when turning on the multiplus. So what we have here? We have here an RCD for AC in and also for the AC out. The problem here is that the neutral conductor is on the same bus bar. On the top here you see two bigger cables running to the RCD of the AC in and also to the RCD of the AC out. And when you connect the neutral conductor from the AC in to the AC out, the RCD will quit its job. So this won't work. Another viewer sent me this picture and asked me for help because the breaker flows out when he activates these three, or also one of these three switches, and it was quite hard for me to find the error because you can't see what the wiring is really about. So we had a quick call, and after some thinking about, he told me that these wires come from the AC out of the multiplus, and so when activating the switch, the AC out is connected to the grid, and this is very, very bad. You can destroy your multiplus this way, and so I better show you how to do things right. So here's a drawing how it should be. Over here on top you have the grid. From the grid you go to the EM24, and from the EM24 to this terminals down there. The neutral conductor of the EM24 is also connected to the terminal, so this is not passed through, this is only connected. You have to add a fuse 350 milliampere there, but that's in the manual, you can read it there. Yeah. From these terminals you have circuit breaker here, and this is the switch on the left side. It's only that you can take the grid apart from the multiplus system, and it's 32 amperes for the multiplus 3000, and for the 5000 it's 50 ampere maximum. So this leads to AC in. Also, all neutral conductors are connected to the terminal here from the AC in. The neutral conductors from the AC out on the other side are connected to a separate terminal down there. And this is important to separate this. Otherwise, the RCDs won't work. So, when you go down from the AC out with the phases, you go to the load transfer switch to the right side. Normally, the outer clamp is used for the neutral conductor, but you have to read on the manual because it's important to have the neutral conductors on the clamp that is transferred first on the switch, and this could be different on each type of load transfer switch, so please read the manual. Yeah, then down there you have the out of the load transfer switch, and it's important to have these bridges down there because normally when you have the switch to the right only, it goes from here to here, and when you have it on the left side, it runs from here to here, so that you can switch from left input to right input to the same output. You need these bridges down there. And then you have the consumer circuits. In normal operation, and this is what most people don't know, the switch is on the right side. So, what does it mean? When the grid is online, you go from here to the circuit breaker to the AC in, and from the AC out to the load transfer switch to the consumer circuits. So the switching in the common way as used with the inverters is done inside the Multiplus. This is a complete automatic process, and you don't care about it. The left side of the switch is only used when the Multiplus is in maintenance, update, or so on. So take this, switch to the right position, and the system will run on its own. So, a bit of conclusion. It's not very difficult, but most of the electricians use these switches for other use cases, and the use case in the Victron system is quite different. So refer to the manual, refer to this video, and you will get your system up and running. Thanks for watching. See you soon. Helmut.